very glad to be here. And let me start by thanking John Varghese for making this all happen. I got a little bit of a glimpse on what's involved in creating such an event, and it's a lot of work that needs to happen behind the scenes. So thank you, John, thank you, Diane, and thank you, Phil. Thanks everyone who worked so hard to make this event happen. So we want to start this morning with something I think is very simple. It's a good start in this day filled with good content. And so I would like to show you some things I discovered around AWS Lambdas. So in the past, this is how it looked to me when I got a new computer or when I reinstalled macOS. Java came on first, and then I put on Tomcat and then maybe MySQL. Those were my go-to developer tools that I needed to have on a computer first. And then of course came like all the tools that you need, IntelliJ and all that good stuff. But how times have really changed. If I now get a new computer, or if I now install, like in the coming days, a new macOS, I will put Python 3 on the computer first, and then I make my machine ready to deploy into Lambda and also into Dynamo DB. So that's what's happening now, and I'm still doing a lot of Java, but Python and Lambda are really on the rise for me. And that's not only true for me, I think. There's a lot of users, like half of the users who are on AWS have adopted Lambda. And the percentage goes up to 80% if you are using containers. Among people deploying Lambda functions, Python is the dominant language. Then comes Node.js and Java, and the other ones are just not really all that popular, I think. So we want to focus on Python today. And so first, when I got started with Lambda, I thought this is like, maybe it's very comparable to just putting your Java code into a VM or putting your Python files into a virtual environment. But digging a little bit deeper, there's actually more than that. And you can find out that what's really happening, that Lambda is running on what's called Firecracker. It's an open source project, and it is running on Intel and AMD x86 64-bit hardware. And this is important to remember. We come to this a little bit later when we talk about how we can package native executables into our Lambda. So it's good to know the exact platform, hardware platform, where Lambdas actually are running on. And then, well, then we say there are certain limits, but it's only a limit if you look at it that way. Like when I was talking about earlier, when I said I always looked at this like more like deploying files into a Java VM, then suddenly having like a whole file system with 512 megabytes available to you doesn't sound much like a limit to me now. It's more like a feature that I have. And so look at the number of files you can open and all that stuff. And so the limit may come in when you say, but how large can my package be that I want to deploy into Lambda? And so there is a limit with 50 megabytes compressed and 250 megabytes uncompressed. So that is currently, I think, a hard limit. But also there, if you run into that, maybe you should split it into multiple functions rather. So there are certain limitations, of course, but there's also a cool little thing here I want to point out. It's called lambdashell.com. You can go there, and it provides you basically a shell into Lambda. So you can try a couple Linux command line tools to run and find out what's available really in one of these micro VMs. So if you get lost during this talk, or if I'm talking too fast or too slow, you can find the documentation for this step by step in much detail on this page. So before we can do anything we want to like quickly look at what I want to show you today. I want to show you a Lambda function that offers basically a web service plus a UI, a web service and a UI that can capture text, that can optionally translate the text into German. It can synthesize the text into either an MP3 format or into a WAV. And the Lambda function will also store data from the requests that comes in a Dynamo DB, and it will play back the audio in the user's web browser. So that's roughly what I want to show you today, all packaged into a single Lambda function. And let's take a quick look maybe how this looks like before we dive into code. And for that, I have to do a quick switch here and go into a web browser. Sorry, I always find this a little disruptive during a presentation. I have to switch. Let's try it. Here's Chrome. And you should see now the web browser with the UI I was just talking about. So here you can write in any text, like I put in the quick brown fox, and you can just hit synthesize.
The quick brown fox jumps over the lazy dog.
And currently we have MP3 selected, and we can, by just clicking the checkbox, have it translated.
Der schnelle braune Fuchs springt über den faulen Hund.
You may have noticed I'm actually a native German speaker, and this is a very excellent translation and speech synthesis, though I was blown away really by when I heard this the first time, and also nuances are really spot on. So if we would change this to red, so there's a red fox actually, so it's not, well, let's listen to this one.
Der schnelle Rotfuchs springt über den faulen Hund.
So this is, like I said, it's an excellent translation and speech synthesis. So that's what we want to build. We want to just build exactly what you see here, a Lambda function that is capable of serving up the web page, consuming the post that comes in when you hit the submit button, and then performs either the translation or right away performs the speech synthesis. So here it is in a little bit more structured detail. So we have an HTTP request coming in through the API gateway. Here we have our first Lambda function that's consuming it, and it can call a second Lambda function that's performing the translation if we wanted it to do that. And then we have here a call into AWS Poly, that's a speech synthesis service. It will also perform the logging of requests into Dynamo DB, and then the regular logging that happens in Python files where you want to log exceptions and stuff goes into CloudWatch. And finally, the translation from MP3 into WAV, we want to use the Linux native FFmpeg executable. If you're familiar with Poly, of course, you know that we wouldn't have to do that, right? We can request Poly to generate the WAV file for us right away instead of MP3. But I just wanted to show you this cool thing, how you can package a native executable into a Lambda function and use that and to execute native code. So I know there's a much better way to do this. So prerequisite, what you need is you need a Python 3 or in my case 3.8 here on your computer. I use PyCharm as my IDE, and PyCharm also has this cool AWS plugin that makes your life a lot easier if you want to deploy into AWS Lambda. But the AWS plugin is just a nice UI on top of the AWS CLI and the SAM CLI. So these tools you need to have installed as well. Again, the document that I pointed you to has these all explained in much detail, how you install it and how you can make it work on your computer. The next step would be you have to have an AWS account, of course. And along the way, you want to create, if you don't have one already, an S3 bucket. This is where when you deploy a Lambda function, your code will be stored first, and from the bucket, it will be deployed into Lambda. All happens behind the scenes, but you need to have a bucket. Moreover, I need you to have an IAM account And that account needs to have 2 policies attached to it. You can do this directly on the account, or you create a group, put the policies into the group, and then put the user into the group, however you want to do this. Again, the document spells it out in much, much detail, how you accomplish these 2 things. Anyways, this is the final thing you need to do in the AWS Web UI. Once that is done, we will not look at it again. Everything else happens through declaration files. So you will end up with your credentials hopefully stored. If you're working on Linux or Mac, it would be in your home directory, hidden folder, AWS, and then the file would be credentials. This is where your key and your credentials would be stored. Let's take a look at the easier function first. So we have the main Lambda function, again, that's performing all the stuff. And then we have a little, very small Lambda function. And we just have that here to show you how one Lambda function can call another Lambda function. This functionality could have easily be packaged into the main Lambda function as well. But just to show you how easy it is to call one Lambda function from another, we kind of split this functionality in its own function here. And this will also show you how you log into CloudWatch from a Lambda function implemented in Python. So let's just switch over into PyCharm here. And here it is, share. So here we have a Lambda function, and this is just a plain Python project where I create a Lambda folder. That's where I typically store all the things that need to be packaged into the Lambda function. So I create a directory inside of my project, call it Lambda. And here is my app.py, the only Python code that we need for this. And it calls the standard login facility. It imports Boto3, the AWS SDK for Python. And here we initialize the logger, set the log level. You could also just use a print statement to print into the CloudWatch log, but then you don't get the nice timestamp. You don't get the benefit from having log levels. So I really recommend doing it kind of the more traditional way and using a login library for that. And here we have the Lambda Handler. This is what will be called when you call your Lambda function. You get a dictionary with all the event data, and you get some context, provides you with information about what is calling your Lambda function. But here we just log the whole event, and then we just extract the text from the event. So this is kind of what you need to be aware of if you wanted to call my Lambda function. It expects a text item in the dictionary that's passed in. And that text then gets translated by just using the service client that we get from Boto. And we say the service that we want to use is translate. And we typically deploy into US West here. And then you just give a couple more parameters. You say, that's my source language, this is my target language. And the translate service will return the translated text to you. That's pretty much what this Lambda function will do. We have no requirements. That file is empty. And I will speak about that in a minute, because you might think, well, why is that red here? And shouldn't that be a requirement? And finally, we have the declaration, the Lambda declaration that all goes into the template.yaml file. So that tells you, like, the function you want to use for your Lambda function. It tells you where it's deployed, and also the name of your handler. So app, that's just a reference to the file name where the Lambda handler has been found. And then this is the name of your handler. Then we define the runtime running on Python 3.8 here, a timeout, the memory that you think you need for your Lambda function. And maybe most importantly, what's the policy? What policy does your Lambda function need to have to run successfully? And since we want to use the translation service, we need to have a translate full access policy attached to this Lambda function. Then we create a log group. This is where if we wanted to log stuff, you saw it in the app.py here, where we said we want to log the event that comes in. So this is where you then later will find that log. So here's the log group, and we call it translate functions, or the translate function is the function name. This would be ENG to GER for Germany, so English to German. That would be the name of our function. And this is the log group that will be created. And we also give a retention here. Otherwise, log files will be stored forever and eventually start costing you money. So we want to really keep an eye on that and keep the retention here to 7 days. That's pretty much it. So it tells you where on your hard drive you can find the function, that it can be packaged and deployed. It tells AWS Lambda what policies it needs. And here we have the log group defined. That's pretty much all we need. And then you just right-click the template, click on deploy, and it pushes it out, creates the CloudFormation stack. Everything happens for you here. There's nothing else for you to do. And that's a very cool and easy way to deploy. That's the code behind the translation here. And let me switch over to the slides again. So we looked at that already. And again, it's very important that you have a function name. Otherwise, one will be created for you, but this is kind of a random name, and then later for you hard to identify if you have multiple functions installed. So now let's talk about Bodo 3. So we saw Bodo 3 to be in the code, being imported. And this is, of course, the huge library that allows you access to all the services that AWS has available for you. So speech synthesis, translation, everything you find on AWS, it's basically in Bodo, providing you a Python interface to these services. Fortunately, we don't need to have this packaged into our Lambda function. It would add up to substantially add to the package size. And so there is another tool I wanted to point you to. It's called InsideLambda.com. If you go there, you can see there is Python 3, 0.8, 0.7, 0.6, and so on. And it will tell you what modules are already provided inside of the micro VM if you have selected Python 3.8, 3.7, and so on as your runtime. And this list scrolls down very long. And so you can see what packages are already inside of the micro VM that you don't have to package with your Python project. And Bodo, of course, is one of those modules that is already provided to you. There's other stuff like the very popular requests module, for instance, and other things. So, but just by scrolling through that list, you will find what's already deployed. And it's now up to you. If you want to package it, you can do that. But with Bodo, it's rather large. And so it makes your, especially if you frequently redeploy, it makes your deployment time so much faster to not have to drag these rather large libraries into your project. So number 2, let's take a look at the little bit bigger function here that does it all, and how is that implemented. And here, of course, the template.yaml file is a little bit more complex. I have a GitHub repo for you where you can find all the code I'm showing you today, but let's just quickly go over the things we find in this template YAML file. So first, I always find it a good idea to make these services available from maybe being called from a REST client and not just through the API and the user interface I'm providing you with. So setting the core settings here to allow every origin is just enabling your Lambda function through the API gateway being called from everywhere. So then a regular REST client can call it too. Here we define declaratively the Dynamo DB. there's basically two ways you could do this. You can do it in code, where you can say maybe on the first call of my Lambda function, the first time it's been used, I check does a Dynamo DB already exist, and if not, I start creating it. You may, however, like run into race conditions doing this. You never know. Multiple people by accident may call your Lambda for the first time. And so it's a much better way to do it declaratively here in the YAML file. And so here we just have a very simple Dynamo DB with just two keys, a sort key and a partition key. And that's it. So that's the definition of your table. And give it the table name, and you will find that table name later in code again. So you have to, this has to be synchronized, of course. The table name here has to then match what you write in your Python code opening the table. Here we have the Lambda function, and we have again some policies. So since we have a Dynamo DB, we want to access the Dynamo DB. And since this Lambda function is responsible for doing the speech synthesis, it needs to get access to Poly. And Poly is, it has more fine grains. So you can specify what do you need from Poly. Do you need to have access to all the voices that are available and stuff like that? And we don't actually. So we can say, give us maybe access to speech synthesis only. And we also want to get access to the logger, of course. And here is another thing. When you want to call another Lambda function from your main Lambda function, you have to have this action enabled as well, that you can invoke another function. So all this kind of specifies the policies that you want to give to your Lambda function. Here we specify the gateway, where what happens if a HTTP GET request arrives at API gateway for our function. So here we have a path and a file name. So this is basically our file server, where our web server, where we provide access to HTML files, JavaScript files, CSS files, and stuff like that. And here we have the definition for what should happen if a post request comes in. And so this is more or less a dynamic way here, like we have dynamically can ask for a file name, and here we put in a function so that it can perform like synthesis and whatever other things you want to have it perform. And this is a little bit of hack, how you keep your Lambda function warm. You know, if your Lambda function isn't called for a long time, then it's not been deployed, and it takes a little while when this initial call comes in. And this is the way how you can keep it loaded and fresh all the time. So this one will basically poll it every 5 minutes. So that keeps it warm, and it will always be preloaded. Here we have the log group again with your Lambda function name and a retention. And this is what you will see once in the moment you deploy your Lambda function. So you want to have maybe the function arn, and also from the API gateway, you want to have the URL where you can call your Lambda function from. So that is what's been output right after you deployed it. So that's a quick run through our YAML file. And so let's take a look at what the Lambda function handler will look like for this function. I showed you the one for the translation. This one looks not so much different. Actually, again, we get an event dictionary being passed in. And the first thing is we look for, does that dictionary contain an HTTP method item? And if not, that just means, well, this function call did not come through the API gateway. And that means this function call came from our, most likely from our scheduler that's trying to keep the Lambda function warm. So here we just respond with bad request, and we are done with that. Otherwise, we are looking for the path, if it's a GET request, and we just put the whole event dictionary that comes in and give it to our post method. So we just branch here out, and depending on if a GET request comes in, we go to our GET function. If a POST request comes in, we go to the POST function that we have implemented in this Python file. And we will then return again the course header here, and return the content type, and the status code back that we get from either the get or the post function. So get and post will behave very similarly and give us these tuple back with a code, a content type, and the content itself. Let's turn our look very quickly to what it's like to be a web server as a Lambda function. So the Lambda function has a subdirectory, call it UI. It has 3 files in it: an index, HTML, a script, JavaScript file, and a style CSS file. This HTML page is so simple. We could have easily put all this right embedded into the HTML file. But separation of concerns is an important concept. And if this grows a little bit, it's an important thing to have. So we split this out. And now, depending on if your file ends in CSS, we set a different content type than compared to JavaScript or to HTML. And then we just open the file, read it in just one step, right? Reads the whole file into the string variable now, and then we return it. So here we have our tuple. It creates 200, the content type and the content. So that is very much all you need to have your Lambda function behave as a web server serving up text content here. Here's a post function, and behaving, like I said, very similarly, returning a status code, a content type. And here we have to remember that this needs to travel through the API gateway back. So it needs to basically be text content, JSON content. So here we receive the content back from the synthesizer that we want to call later. And this content is already in string format. So we have to be aware of that. And here we just dump it into a field we call B64, already hinting that this content will be base64 encoded. So this is how the content travels back into the web browser. We also set the content type based on the request that the user sends in. It could be either audio wave or audio MPEG. And that's pretty much all I wanted to show you here. This also has a call to our request DB create, which we also will take a look at in a minute here. That's how we log into Dynamo DB, and we want to log the IP address of the user that comes in and the text that he requested to be synthesized and or translated. So that's been stored in the Dynamo DB. But that's all there is to the post here. And so we cover, yes.
Hi, this is Phil. I just wanted to let you know you're coming up on a half an hour. It's been about, it's about 10 o'clock now, California time.
All right, I will speed up a little bit. So we have, the next thing we want to call out is how we translate and how we call the speech synthesizer. So again, we use the now already familiar Bodo library for that. And we import client just like we did before when we call the translate. So here we call not translate, we call poly instead. And a little bit digging in the documentation, and you will find out that there's different engines available, a standard engine and a neural engine. Neural engine, the name already hints at it, has a much smoother and much more natural speech synthesis, but it's not available for all languages. So if it's English, we can use the neural English. If not, we have to use the standard engine. Then you will find out that different languages provide different voices. So we have a bunch of female voices and male voices and child voices for English. And the selection gets a little bit less when you go to foreign languages like German and Spanish and so on. So, but you still have choices. So for the German voice, we have Marlene and we have Hans and Vicky, I think. So after a couple examples, I ended up with Marlene as my favorite German voice. So we only need that, of course, if translation was selected. Otherwise, we go with Neural, we go with Joanna, and we just dump in the regular text that came out, and we use MP3 as our default format. We call the synthesizer, we get the audio, we get the result in the audio stream back, and here we perform the encoding. If the user, however, selected wave, we call MPEG to wave in between with our binary data. But that will be our native call. Take a look at that in a second here. But what we have to do is we have to encode the binary data in something that can travel easily through the API gateway back to the user. So we encode it into a string. So first it goes into a byte array, and then we encode the byte array into a UF8 encoded string. And that's what we are getting back here. That's why you see synthesize accepts a string, translate is a Boolean, here's our format, and here we are returning a string back. So that's a little hack how you can transport binary data through the API gateway back to the user. So the FFmpeg hack I wanted to show you real quick. So 1 minute. This is a native library that we just drag into the Lambda, and it will be deployed. The only trick you have to do is you have to copy it into the temp directory that you have with your Lambda and make it executable. And then you can easily call it with subprocess, which is just a standard module in Python, subprocess popen. You call it just like you would in a regular Linux shell script or something like that. All right, with that, I'd like to see you all in the face-to-face chat, and you should see a link for that now in Loudswarm. Thank you.